So earlier in this year, we spent a lot of time on linear functions, and most recently, we've been spending a lot of time on quadratic functions. And what we're going to do now is just compare them a little bit and mainly identify whether or not we have a quadratic function from a table or not. So earlier in the year, we looked at linear functions and we looked at a table and we looked for that constant rate of change. We were looking to see if you were constantly adding 2, for example, or subtracting 3. And because it was constant, we had a linear function. But now what we're going to be doing is looking at tables and seeing if we can recognize a pattern and see if it's a quadratic function or not. So you can use patterns between consecutive pairs to determine which type of function models the data. So again, we talked about linear functions earlier in the year that have a constant first difference. Now we're going to look at quadratic functions that have a second difference that is constant. And I'll explain in a moment what exactly a constant second difference is. But keep in mind that we're looking at consecutive x values, so those x values need to be constant, otherwise these patterns do not hold true. So this is an example of a quadratic function, and what I'm going to be doing is explaining what a second difference is and how you can use that to identify a quadratic function. So again, looking at those x values, you have consecutive x values. You're constantly adding 1. So before you can look to see whether or not you have a pattern or not with your y values, you have to check to make sure your x's are consecutive. Now from there, we can move on to our y values. So how do you get from 0 to 1, 1 to 4, 4 to 9, and 9 to 16? Well, you're adding 1, then you're adding 3, then you're adding 5, then you're adding 7. So that right there is your first difference. And as you can see, they're not constant. So what we want to do is do that again and look from 1 to 3. How do you get from 1 to 3? How do you get from 3 to 5? How do you get from 5 to 7? And you should notice something about these numbers as well. You should notice that they're all odd, and to do that, you are adding 2 each time. So now, by doing this process again, that is called your second difference. And because this has a constant second difference of adding 2 each time, this table does in fact represent a quadratic function, which we already knew it should have. So now we're going to look at some examples where the function is not given, it's just going to be a table, and we need to determine whether or not we have a quadratic function or not. So again, tell whether the function is quadratic and explain. So this is the table that we're given. And now first what we want to do is look at those x values to see if they're constant. So you're going from -2 to -1, -1 to 0, 0 to 1, 1 to 2. So you do have that constant addition of +1 for your x values. Now you can move over to your y values and look there. So you're looking at how do you get from -9 to -2? How do you get from -2 to -1? How do you get from -1 to 0? And how do you get from 0 to 7? Well, first you're going to add 7, then add 1, then add 1 again, then add 7. So again, not constant. So now we want to do this whole process again and look at how do we get from 7 to 1, 1 to 1, and 1 to 7. Well, we are going to be subtracting 6, then adding 0, then adding 6 again. So because these numbers are not the same, they are all different, this is not a quadratic function because the second difference is not constant. So when it says explain, that's all you really need to do to explain. The function is not quadratic. Why? Because the second difference is not constant. Next example. Tell whether, again, this function is a quadratic and then explain. So the same process of looking at your x values is what you need to do first to see if those are constant. So in this case, you're adding 1 again each time. So your x values are consecutive and are constantly changing or constantly adding 1. Now you need to look at your y values and see what the first difference is. So to go from 4 to 1, 1 to 0, 0 to 1, and 1 to 4. You're going to be subtracting 3, then subtracting 1 again, then adding 1, then adding 3. So you hopefully see patterns and kind of know from previously that quadratics are symmetrical. So this does look promising for us to have a quadratic function here. But what we really need to do to determine is look at that second difference. So how do you get from -3 to -1? You're going to add 2. How do you get from -1 to +1? You're going to add 2 again. And how do you get from 1 to 3? You're going to add 2. So you have that constant second difference of adding 2 each time. So because of that, this function is a quadratic because the second differences are constant. Again, this is all you need to do when it says explain. The function is quadratic, the second differences are constant. So that's what we're looking at, the second difference to determine whether or not you have a quadratic function or not.